Alright, today we're working on 10.8 Polygons and Tessellations. And what I want you to do is go ahead and hit pause and copy this information down first. Alright, it says a polygon is a simple closed figure formed by three or more straight line segments. There are no gaps or overlaps. That is a polygon. A regular polygon has all sides and all angles congruent. Okay, for example, a square has all sides and angles being congruent. An equilateral triangle also has all sides and angles that are congruent. Those are regular polygons. A polygon in general, again, is a closed figure made up of line segments. Got to have three or more, and they have to be straight to be included in that with no gaps or overlaps. Now we can see that we have the types of polygons and the number of sides that are related to that. One thing you need to be looking at is the first part of each of the words. Okay, that is what's helping you determine what the number actually relates to. Okay, so now let's look at the next question, and it's a very simple question, just simply stating determine whether the figure is a polygon. If it is, then classify the polygon and state whether it is regular. If it is not a polygon, explain why. So go ahead and hit pause and solve this. Alright, the answer to this is no, it is not a polygon. And the reason for that, the reason behind that, is because it has that extra line. Okay, it has the gap or the overlap. That line does not make this a polygon. However, if we were looking at just the inside and taking this particular line out of there, then it would be considered a polygon because it has it is a closed figure made up of three or more line segments. So the way I had it originally, the answer to that would be no. Okay. Now that I'm looking at this, when I pull that line away, is this a polygon? Yes, this is. Okay. And is it regular? The answer to this is, it's a little difficult to determine, but it is a no. Okay, because the line segments and the angles are not congruent. They are close, but they are not. So let's look at this next one, letter B and C. I'll let you go ahead and solve both of those. So go ahead and hit pause. Letter B, the answer to this is yes, it is a polygon. Okay, it is a polygon. Is it regular? No, it is not. Okay, and it does say to name it, and you've got 1, 2, 3, 4, 5, 6 sides. Therefore, it would be a hexagon. Okay. This particular figure is another yes, it is a polygon. And it has 1, 2, 3, 4, 5 sides. Therefore, it is a pentagon. And they also want to know, is it regular? And the answer to this is yes, it is regular. So it's a regular pentagon because all the sides are congruent and all the angles are also congruent. Okay. Now it says find the measure of an angle in each polygon. And I want you again to go ahead and hit pause and to solve this. So go ahead and hit pause. Actually, not solve it. Go ahead and hit pause and write this information down. All right. So what I want you to do is when we're looking at this, you can see that n minus 2, okay, that is n standing for the number of sides, minus 2 times 180 degrees, it's actually 180 degrees, is why we're doing that, because it does create triangles, and I'll show you an example of that. The sum of all angles, okay, that's what this part of the formula represents. This right here is the actual formula. That is taking the number of sides minus 2 times 180 degrees. Then you're going to divide that answer by the number of actual sides itself. Okay, this will give you the measure for one angle in a regular polygon. It has to be regular, okay, meaning all sides and angles are congruent. Okay, so when I do this, a regular polygon, for some reason my MobiPad's not working here. Well, we'll try this. So I have a regular octagon, okay, and a regular octagon has 8 sides, okay? So we're going to plug that in. 8 minus 2 is 180 degrees, or times 180 degrees, over the 8 sides. So then this is going to be 6 times 180 over 8. So when you take that, you end up with 6 times 180 which equals 1080 over 8. So then you divide that by 8, and you get a total of 135 degrees. That is for one angle. Okay? Let's look at the next one. I'm going to let you hit pause and go ahead and solve this for an equilateral triangle. So for an equilateral triangle, again, we have n minus 180. Whoops. N minus 2, sorry, equals 100, or times 180, divided by the number of sides. So we have equilateral triangle. Triangle has 3 sides. So 3 minus 2 times 180 over 3. 3 minus 2 equals 1, and 1 times 180 is 180 over 3. And then when you divide that, you get 60 degrees. Okay? If you have questions, again, please take note of that, and we'll talk about it further in class. The next one is a tessellation. It is a repetitive pattern of polygons that fit together with no overlaps or holes. The sum of the measures of the angles where the vertices meet is 360 degrees in any tessellation. So the question is, can you use tiles that are equilateral triangles to cover the floor? And explain. Okay? Use tiles. For example, if we were going to, if they were rectangular or square, any of those would work. We're going to use rectangles. And if we were to lay them out like this to cover a floor, you can see how that floor would begin to look. Now the question is, the vertices, where all 4 of them connect, okay, will they equal 360 degrees? Well, if they're all 90 degrees, 90 times 4 is 360 degrees. So therefore, the answer to this is yes, okay, if they were rectangles. Now this says if they're equilateral triangles. So if these equilateral triangles, again, all have congruent sides, it would look like this. and like this. Okay, it's begin to look like this when they all go together. Now, if we recall in the last question, it was 60 degrees was an equilateral triangle. So we have 1, 2, 3, 4, 5, 6. And does 60 degrees times 6, does that equal 360 degrees? Yes, it does. So the answer to this is yes. And the way to explain it is exactly how I told you here, is that you have 6 angles that come together in one vertex, and they would equal 60 degrees each. So you multiply those together to get you 360 degrees. Okay. I'm going to show you in class some more examples of tessellations as well, to get a little bit better of an understanding with this. But this is the basis of it. Okay. Have a great day, and we will see you tomorrow.